Welcome to today's lecture on the product and quotient rules for Math 215. Biocalculus. We'll discuss the product rule, then we'll discuss the we've seen before. That is, products of functions we've seen before and quotients of functions we've seen before. Okay, so here's what the product rule says. It says if a function consists of just the product of two factors, one function multiplied by another function, then its derivative is the derivative of the first factor times the second factor plus the first factor times the derivative of the second factor. To differentiate a function using the product rule, we need to first locate the two factors and make sure we can differentiate each of those two factors. There are some functions that can be differentiated using the product rule. We've seen how to differentiate each factor before. X times e to the x squared times ln of x, x to the 7th times sine of x cubed minus x squared plus x minus 1, x squared plus x minus 1, and x plus 1 over square root of x. So each of these factors, we've seen in an earlier lecture how to differentiate polynomials, how to differentiate e to the x, differentiate ln, how to differentiate sine. Here's an example. Let's say the function is just the product of these two polynomials. Now, one option is just to expand all the terms. So this is really cute, because that would take a lot. There'd be a lot of terms there. Instead, let's use the product rule with f of x being the first factor and g of x being the second factor. In that case, we can differentiate f prime, as we saw on Friday's lecture, using just the power rule combined with the sum and difference rule and the constant multiple rule. Derivative of x cubed minus x squared plus x minus 1 is 3x squared minus 2x plus 1. And the derivative of x squared plus x minus 1 is 2x plus 1. Remember, the derivative of any constant is 0. So by the product rule, what do we get? We get the derivative of the first factor times the second factor plus the first factor times the derivative of the second factor. And if we apply that to the functions listed earlier, here's what we'd get. Derivative of x times e to the x. Well, remember, the derivative of e to the x is itself equal to x. So the derivative of x to e to the x is 1. The derivative of x is 1. So it's 1 times e to the x plus, now we leave x alone. Leave x alone, differentiate the second factor. We get x times e to the x. Second function, h of x, is x squared times ln of x. We differentiate this function to get 2x times ln of x, plus, where does this x come from? This comes from, well, x squared is left alone. The derivative of ln of x is 1 over x. X squared over x is just x. So we're left with 2x times ln of x plus x. H of x is x squared, x to the 7th times sine x. Well, if you recall from the previous lecture, derivative of sine x is cosine x. Derivative of x to the 7th, we can just differentiate it using the power rule is 7x to the 6th times sine x. So we get 7x to the 6th, derivative of the first factor, times the second factor, sine x, plus x to the 7th times cosine x. If the function is x plus 1 over square root of x times x plus e to the x, okay, so it's the same thing here. This is x plus x to the negative 1/2. Differentiate that using the power rule. So we get derivative of x is 1, derivative of x to the negative 1/2 is negative 1/2 x to the minus 3/2. So the derivative of the first factor here is 1 minus 1/2 x to the minus 3/2. Leave the second factor alone, and we add the first factor left alone times the derivative of the second factor. In this case, it's 1 plus e to the x. Again, derivative of x is 1, derivative of e to the x is e to the x. Okay, so now let's move on to the quotient rule. What does the quotient rule say? The quotient rule says that if we have a function that consists of the quotient of two functions, then its derivative is the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator, all divided by the denominator squared. So you can memorize this by low d high minus high d low over low squared. That's one way of memorizing it. It's important here in the product rule, the order didn't matter, but here it does, because if the first term, say, was the denominator differentiated first, we'd have an answer that would be incorrect. It'd be off by a sign. So it's important here, which derivative comes first? The derivative of the numerator times the denominator, and then subtract the numerator times the derivative of the denominator. To differentiate a function using the quotient rule, we need to first identify a numerator and the denominator that can be differentiated using the rules we know already. Here are some examples of functions that can be differentiated using the quotient rule. E to the x over x, we've seen how to differentiate e to the x and x before. X plus ln of x over square root of x, we've seen how to differentiate x, ln of x, and square root of x before. Sine of x over x squared, we've seen how to differentiate sine x and x squared before. X minus 1 over x plus 1, those are both polynomials of degree 1. And sine x over cosine x. Here's an example. Let's say e to the x over x. Let's differentiate that using the quotient rule. Derivative of e to the x is just itself, e to the x. But the denominator function is just x, its derivative is 1. For the quotient rule, this derivative is x times e to the x minus e to the x over x squared. So this is the derivative of the numerator, e to the x, times the denominator, x, minus, now we differentiate the denominator, just 1, times the numerator, left alone. Okay, and if we do the same thing for these other functions, this is what we'd end up getting. X plus ln of x, so here, for the numerator, 1 plus 1 over x. We leave the denominator alone, square root of x. We subtract now the derivative of the denominator times the numerator, left alone. And here, remember, square root of x squared is just going to be x. Okay, that's assuming x is positive. If we have sine of x over x, we get sine of x over x squared. Okay, so we're going to say, well, this is going to be x squared, the denominator left alone, times the derivative of the numerator. So that derivative of sine x is cosine x, minus the derivative of the denominator, 2x, times the numerator, sine x. If our function is x minus 1 over x plus 3, its derivative is 1. The derivative of numerator and denominator is both 1. So we get 1 times x plus 3 minus 1 times x minus 1. X plus 3 minus x minus 1, we get 3 minus x plus 1, so we get 4. X minus x is just cancelled at 0, so we get 3 minus negative 1 becomes 3 plus 1, which is positive 4. We divide by the denominator squared, x plus 3 squared. If our function here is sine over cosine, notice this is actually the same as the tangent function. We get the derivative of the numerator, which is cosine, times the denominator, cosine, minus the numerator, sine, times the derivative of the denominator, which is minus sine. Here we get cosine times cosine, that's cosine squared x, plus sine x, times minus sine x, that becomes cosine squared plus sine squared is 1 over cosine squared x, which is secant squared x. So secant is defined as 1 over cosine. Now the reason this happens is that cosine squared plus sine squared is equal to 1. It's called the Pythagorean identity. So you'll see this, you'll probably see this in some other sign problems. The derivative of the tangent function is secant squared. Actually, you can differentiate any other trig function combined using sine and cosine just from the product quotient rules. Let's differentiate a function using. Now, there are some times when you might have to differentiate a function using both the product and the quotient rules. So in this case, let's say the function is 2 square root of x plus x e to the x over x minus 5. Here, the numerator is 2 square root of x plus x times e to the x. If you notice, the second term in the numerator, to differentiate it, requires the use of the product rule. To differentiate x e to the x, what do we need to do? We need to use the product rule and differentiate the second term. The derivative of this function is x to the negative 1/2. That's just here, square root of x is x to the 1/2. So to differentiate, 1/2 comes down. We get 1/2 times 2, which is just 1. And then we get x to the negative 1/2. That's because 1/2 minus 1 is negative 1/2. Differentiate the second term, x e to the x. We get derivative of x is 1. We're left with e to the x, and then we add x times the derivative of the second factor, which is e to the x. Now you can factor on e to the x, which those terms, to get x plus 1 times e to the x. And the derivative of our numerator becomes 1 over square root of x plus x plus 1 times e to the x. The denominator then is x minus 5, and its derivative is just 1, so that is pretty straightforward. But the only thing different really here is that to differentiate the numerator, we need to use the product rule. And then we just plug everything into the plug and chug into the quotient rule. We get 1 over square root of x. That's the same as x to the negative 1/2, plus x plus 1 times e to the x. That's the derivative of the numerator times the denominator, x minus 5, minus the numerator, 2 square root of x plus x e to the x, times the derivative of the denominator, which is just 1. Remember, 1 times any function or number is itself. So we're just left with this second. These last two terms here, we're subtracting 2 square root of x and x times e to the x. And then we divide by x minus 5 squared. That's just dividing by the denominator squared. Okay. Now in this case, we're not really too worried about simplifying. It is possible to simplify this here, but I mean, it's not really going to be that useful. There aren't too many like terms. If there were more like terms in the numerator, then simplification would be more appropriate. So we'll see later on how that plays out when we get to second derivatives and graphic.